Hello everyone, and welcome to the lecture on isomorphic mapping. Last week, you started to explore various mapping techniques such as choropleth mapping, dot density mapping, proportional symbol mapping, and graduated symbol mapping. This week, we're going to get into one of my favorite mapping techniques, isomorphic mapping. Now, take a look at the two maps that you see on screen. You're going to notice one is very similar to what we are used to creating, a graduated color map or choropleth map. A graduated color map essentially takes some type of enumeration unit or geographic boundary, in this case counties, and quantifies the phenomena based on that enumeration unit or boundary line. So you have something that looks like this. We all know that phenomena don't necessarily care about boundaries like rainfall and temperature and so forth, and sometimes organizing things by arbitrary enumeration units such as county boundaries, state boundaries, is not the best way of displaying and representing geographic data. So another way of doing it is this way, where you create a surface that joins areas of like values, and you have something that really ignores those arbitrary boundary lines and then looks a little bit more closely at where the phenomena is actually occurring. We are all very familiar with isomorphic mapping because we watch the Weather Channel, we've seen temperature maps and precipitation maps and so forth. But essentially what an isomorphic map does, it depicts smooth continuous phenomena, things like rainfall, contours, which you're very used to working with, barometric pressure, and topography as a few of those examples. And if we take a look at this particular example on hydrogen ion concentration in the United States, what you see here is that a whole bunch of data points with the ion concentration. And essentially what this isomorphic map is doing, it's connecting areas of similar values so that you can see the geographic spread over a continuous surface. So this kind of map is created by a process called spatial interpolation. This essentially is the procedure for estimating the value of properties at unsampled sites within the area covered by existing observations. So if we look at this map, we can see that the areas of very similar values are grouped together so that you can see the trend in the data a little bit easier. So interpolation predicts values for a cell from a sample of data points, and it's based on the assumption that things that are located spatially closer together are more similar than they are if they're further apart from one another. This is essentially the concept of spatial autocorrelation, and this is a geographic concept as well as one in GIS, and spatial autocorrelation essentially says that objects located closely to one another tend to be more similar to each other than items located further apart. And we can even just take the example of a neighborhood. The neighborhood in which you live, the people that live there are probably very similar in characteristics to what you are, and as you move away from where you are, they tend to be more different. So demographics is one of the areas that spatial autocorrelation really does play out. So why do we interpolate? We interpolate because if we had to take samples at so many different points, it would be very time consuming and not necessarily the best use of time. This allows us to basically take those unsampled areas and use places that were sampled to predict what that area would be. There are various types of interpolation methods in Arcgis. We have inverse distance weighting, IDW, kriging, spline, natural neighbors, and trend. IDW tends to be the one that is the most commonly used. However, depending on what you're doing, you might want to explore some of the others. Essentially, they all just use different algorithms to create the surface from a group of points. So where do you find these tools? You can find them either in your Spatial Analyst extension or your 3D Analyst extension. So, I have these definitions for each of the interpolation types up here. However, I'm not going to read them. You can do that yourself. And we're just going to get into Arcgis and explore the various methods. So here we are in Reservoir Park, Harrisburg. It doesn't look like anything much. Essentially, it just looks like a boundary and a bunch of points. What this is all these different points that you see here were random points taken by an advanced GIS class several years ago. We were trying to create an elevation surface for Reservoir Park, and so each student was given a GPS unit just to go take a bunch of random points, and then we combined all of those points together into one data set so that we could create a digital elevation model from all of those points. We used a Garmin GPS, which isn't necessarily the most accurate, but when you do that, you can get an altitude reading as well. So if we open up our points and look at our attribute table here, you're going to see that there is an altitude field in this attribute table. So here we have the latitude, longitude. If we scroll over just a little bit more, here's the altitude field. So what we're going to do with this is we're going to interpolate a surface so that we have a digital elevation model of sorts for Reservoir Park. So to do that, you first want to make sure that you have activated your extensions up here in customized extensions, that you have 3D and Spatial Analyst on, or that's going to be problematic. Your tools aren't going to work. Then you come over to your toolbox and you find your interpolation tools. In the 3D Analyst toolbox, it's under raster interpolation, and then in the Spatial Analyst toolbox, it's under interpolation. So it doesn't really matter which one that you use, the tools do the same thing. I'm going to just stick with the ones under 3D Analyst. So if I double click on raster interpolation, I'll get my tools, and I'm going to do IDW. And my dialog box comes up, and just as a reminder, I want to mention this area over here, the hide and show help. I am a big fan of keeping the show help open at all times because it gives you good little hints as you're moving through your tools. When we get to some of the more complicated tools, this can be really helpful because it gives you hints on what to include in each of them if you're unsure. And that has saved me many times, just knowing what the definition of everything is. So to get started, we input our points. And then we select the Z value field, or the elevation or altitude field. We save it where we want to put it. I'm just going to keep it in this default path. But when you go to save yours, make sure that you're driving it to the appropriate folder and calling it an appropriate name. Notice in this file path there are no spaces anywhere, and there's no spaces in my file name. Make sure you follow that convention because it can be problematic if you don't. So I'm going to keep the defaults here, and now I'm going to click on the Environments tab or button, and this brings up our environment settings where we can actually do even a little bit more with this. For those of you in intro, you probably never really played with this. For you, those that were in remote sensing, you may have seen this before, but if we hit on Processing Extent, we want this to create a raster based on the boundary of our park, and instead not the boundary of our points. And to kind of go back and explain what that means, if we look at this, when we would create a surface from our points, it creates a surface using the westmost, eastmost, northmost, and southmost points. So when this raster would be created, it would actually be cutting off certain areas of Reservoir Park. To make that not happen, we can say use the processing extent as our boundary so that the raster covers the entire park. So that's what I'm going to do, is change my processing extent to the same as layer park, my park boundary, so that my raster covers the entire park rather than just my points. This is something to remember for the Pennsylvania temperature map that you're going to be creating this week. If you don't set this as the layer of the Pennsylvania boundary, you're going to have a raster that cuts off certain areas of Pennsylvania, and that's not what we would want to happen. So hit OK, and then OK again, and the tool will start running down here. You can see that it just keeps saying IDW over and over, and then we have a globe that spins. When it's successful, it adds it to the map and puts a green check there, and then it gets out of here. Now, before moving on a bit, I do want to discuss the usage of tools. If for whatever reason your tool failed, make sure that you're following the naming and saving conventions for your data. Also, make sure that when you do rerun the tool, that you don't call it the same thing that you did the first time, because you're going to get an error message regardless at that point. And then the third thing is, if your tool keeps failing over and over and you really don't know why, you think you're doing everything wrong, the best thing to do is to save your ArcMap project, close ArcMap, and reopen it, rerun the tool. 95% of the time, that's all you need to do, because once you get an error message, it gets caught in a little bit of a loop and it can't get itself out. Shutting down ArcMap erases all of that. So just a little tip so that you don't get frustrated when tools fail. I'm going to just set my boundary hollow so I can see through it, so I can see my surface. And what you can see here is that it essentially created a surface that connected areas of elevation. We can turn off our points at this time because now we have our nice surface that is representing topography instead of the points. And hold on one second, my light went off and I have to turn it back on. Sorry about that. Okay, so now that we have this, notice that we have it for the entire park. And what we can do now is the same thing that we have done with using digital elevation models. If we wanted to, we could actually create contours from this. And that's actually something you're being asked to do for your Pennsylvania temperature map, is also add contours to the temperature map. To do that, we go to our raster surface tools, contour, and I'm going to make this, looking at our range here, it says 144 to 187. That's not really a big elevation difference, so I'm going to use maybe 5. See what happens. Our contours are created, and now we have 5-foot contours for our surface. And if we open up that attribute table, you can see that you have a contour field, and you could then label based on the contour field so that you knew what the contours were. So that's how to create contours from this. One last thing before we end this particular video. Notice that when your IDW came in, it came in with 6 significant digits after the decimal point, and that's probably not necessary. And if anybody would look at this in a legend, it would be like pretty much unreadable. So you want to clean that up for your map user to let them have a happy experience in interpreting your map. So what you can do is just double click on your layer, and the properties will open at some point. Yep, they'll open at some point. And when they do open, we can go to our symbology tab. And under label, we can just click on format labels and change this so it's not so ugly. And I'm actually going to do 0 on that. And this makes it a lot more of a readable legend than what we had previously. So with that, that's a quick overview of interpolation. You're going to practice it during a Pennsylvania temperature map. You are being given an Excel spreadsheet of selected Pennsylvania cities. That spreadsheet has the temperature for that particular city in. You have to figure out how to get the data into that Excel spreadsheet into Arcgis. You're going to add the Pennsylvania boundary, and then you are going to interpolate a surface and create contours for that. So good luck with that, and if you have any questions, just shoot me an email or post a question on the discussion board.